So ladies and gentlemen, when going over a factoring technique, so far we've discussed, pretty much in this class so far, we have discussed how to factor when we have a form of y equals ax squared plus c. This is what we use the square root form, right? You pretty much you set it, always you set y equal to 0. And then you put c, you subtracted pretty much c divided by a, and then take the square root. Then the next form, that was the square root method. The next form we worked on was factoring out your GCF. And basically what we did is we factored out an x, as well as if there was another common factor. And then we used the zero product property to solve. Now, for this next one, you guys can see that for the standard form, we have everything involved right now, everything here. So what we're going to do is we need to create another system to be able to factor this. We can't just solve c and then try to solve for x because we have two x's. We can't just factor out an x like we did over here because we now have this value of c, which now all factors don't have c in them. So we need to create another factoring technique that's going to help us factor when we have three terms. And the most important thing, the one that we're going to work on today, is when a is equal to 1. We still have three terms, but a is equal to 1. And to do that, we're going to do what we'll call the diamond method. But rather than create a diamond, I just like to create a x. All right? And when doing this diamond method, which is I'm just going to call it, but even though I'm creating an x, what I'd like you guys to do is label your c and your b. And then basically, you're going to multiply, put the c up top. You're going to put a multiplication up top and a plus sign on the bottom. And basically, what that's going to tell you to do is what that's going to allow us to do is we're going to find the values that multiply to give us c and the values that are going to multiply to give us, or add to give us b. Those values we'll call p and k. And then what we'll use is we'll take those values, and those are going to be our factors. So the first step is we always solve, set that equal to 0. And then we'll have x plus p times x plus k. Now we have our factors, and we'll be able to solve for p and k, or solve for our zeros. All right? So this is just a very standard form of this. I'll obviously go through a problem for you so you guys can see how exactly that works. But basically, to solve for this, that's